In this class, we're going to talk about logarithm. We're going to start by looking at the various laws of logarithm, okay? We are going to look at all these 11 laws. You can see the first law is the product rule. The second is the quotient rule. The third is the power rule. The fourth is the change of base. And the fifth is the log of the same base. The sixth, the inverse properties of logarithm. The seventh, the log of a product power. 8th, the log of a quotient power. 9th, the base power law. 10th, the equality properties of logarithm. Then we have the 11th, the log of 1. Okay, let's start with the the product rule. The product rule, that is the first rule. The product rule. According to this rule, if you have the logarithm of the product of two or more number, for example, let's say we have log A multiplied by B. According to this rule, we are going to have log A plus log B. Do you understand? That is, when you have the logarithm of the product of two numbers, A and B, the result will be the sum of the log. Are you getting it? The logarithm of the product of two or more number is equals to the sum of that log. So let's say you have log 3 times 2. This will be equals to log 3 plus log 2. Do you understand? Okay, let's change it. Let's say you have log 3 times 9. This will be equals to log 3 plus log 9. Do you understand? So let's now say you have more than two numbers. Let's say you have the log of A times B times C. This will be equals to log A plus log B plus log C. Do you understand? So that is the law. The sum of the product of a log, or the log of a product, is equals to the sum of the log. Are you getting it? So let's now change it. Let's say you have log 2 times 3 times 7. This will be equals to log 2 plus log 3 plus log 7. Okay, so that is it. These properties that you see here is known as the product rule. Do you understand? Okay, let's look at the next rule here. We have the quotient rule. According to the quotient rule, rule number 2, the quotient rule. You know that quotient simply means division. You understand? Quotient simply means division. So let's say we have the logarithm of the quotient of A and B. Okay, this will be equals to log A minus log B. This indicates that if you have the log of a quotient, the log of a quotient will give you the difference of the log. Are you getting it? Please kindly pay attention to all this law, because when we get to so that you won't make mistake when you're dealing with questions as touching this concept. Are you getting it? So now, when you have the log of a quotient, the log of a quotient will give you the difference of that log. Do you understand? So that is it. Now let's say you have log 3 all over 2. This will be equals to log 3 minus log 2. Okay, you can see how the laws work. Are you getting it? So when you have division, you're going to have the difference of that log. Do you get it? So let's change it. Let's say you have log x all over y. This will be equals to log x minus log y. Do you understand? Okay, so this second rule that you see here is called the quotient rule. Do you understand? Okay, let's look at the power rule of logarithm. According to this rule, if you have a logarithm raised to a power, the result, for example, let's say you have log A base B raised to the power of C. That is, log A is raised to a power, which is C. The result of this will be the product of the power and the log. Do you understand? Please listen and listen attentively, okay? If you have the log raised to a power, if a log is raised to a power, the result will be the product of the power and the log. So that means log A to the power of C, or log A base B to the power of C, will give you log, this should be B, sorry. Will give you log A base B multiplied by C. Do you understand? Okay, let's try this. Log x raised to the power of y base z. this will be equals to the power. We multiply the log. So I'm going to have y multiplied by log x base z. Do you understand? Okay. Another one. Let's say you have log p to the power of q. Let's say the base of this logarithm is maybe y. The result will be q multiplied by log p base y. Do you understand? Okay. Let's say you have log x raised to the power of b. The result of this logarithm will be b log x. Do you understand? Okay. Another important thing that I want you to take note is that anytime you are given logarithm and the base is not included, know that the base of that logarithm is 10. Do you understand? Listen and listen. Anytime you are given a logarithmic question or any log question, and the base is not included, for example, this kind of question, you can see that I didn't put the base. The base of this logarithm is 10. So don't forget that. Okay, let's look at another one. Let's say you have log y base t raised to the power of z. What will be the result of this? This will be z multiplied by log y base t. This law that you see here is called the power rules of logarithm. Do you understand? Okay, so let's look at number. Let's say you have log 5 raised to the power of 2 base 10. The result will be 2 multiplied by log 5 base 10. Do you get it? Okay. Log 20 raised to the power of 4 base 5. The result will be 4 multiplied by log 20 base 5. So anytime you have the log of a power, the result will be the product of that power and the log. Don't forget, okay? Anytime you have the logarithm of a power, when you have your log raised to a power, the result will be the product of that power and the log. And also, you can reverse this. Hello? If this log is equals to this log, that means that this log is also equals to this. Do you understand? What I'm trying to say is this. Here, please listen. Here we have log a to the power of c base b equals to c multiplied by log a base b, right? Also, if you have c multiplied by log a base b, this will be equals to log a raised to the power of c base b. That is the power come back to this point. Do you understand? That is the power that is multiplying the log come back to the power of the log, becomes the power of the log again. Do you understand? Okay, just like what you have here, y log x base 2, this will be equals to log x raised to the power of y base 2. Do you understand? It's just as if I reverse what I have here. I reverse the case. Do you understand? If the log of a power is the product of that power and the log, that means the product of the power and the log is also the same thing as log of a power. Do you understand? It's simple. If the log of power, if the log a to the power of c is equals to c times log a, that means c times log a is also the same thing as log a to the power of c. Do you understand? So that is what I'm trying to say. This one also can be reversed. Q multiplied by log p base y will be equals to log p to the power of q base y. Do you understand? The power come back to the product that is what is multiplying the log here becomes the power of the log again. Do you understand? So it's just as if reversing the case. I want to attempt this. Reverse this case, reverse this, and the others like that. Okay, let's look at the change of base formula. But before we look at this, I want us to talk about these properties of logarithm. That is the log of the base. That is when you have the log of a number whose base is the same as that number, what are you going to have? For example, let's say you have log a and the base here is also a. What will be the answer? The answer here will be 1. Do you understand? Log b base b, the answer will be 1. Anytime what you have here is the same as the base, the result will be 1. Do you understand? Okay, now let's say you now have log 5 base 5, the answer will be 1. Log 7 base 7, the answer will be 1. Log 100 base 100, the answer will be 1. Anytime what you have here is the same as what you have here, the result will be 1. Do you understand? Okay, now let us go back to the fourth law, which is the change of base law. According to this law, let's say we have log a base b. Please pay attention, okay? It's simple. Let's say you have log A base B. It is possible to rewrite this logarithm as log A base A all over log B base A. What I have done here is that I have changed the base of the logarithm. And what do I change it to? I change the base of the logarithm. The base is B before, do you know? Then I change the base to A. Do you understand? So since log A base A will give me 1, so the result of this will be 1 all over log B base A. Do you understand? Okay. Let's say we have log X base Y. If I want to change the base of this logarithm, I'm going to have, you can change it to any base. Do you understand? You can change the base of the logarithm, you can change it to any base. So let's change this to log X base A all over log Y base A. So I've not done anything, you can see now. So here, I change the base of this logarithm to A. I change the base of this logarithm to small letter A, right? So that means if I have log A base A, since we know that the log of the same base, the log of a number to the same base will give me 1. That means log A base A will be 1. But here, the base here is A. And because if what you have here is the same as what you have here, the result will be 1. Do you understand? So what you see on the board is called the change of base formula. Do you understand? So master this, okay? You can change the base of a logarithm. Are you getting it? You can change the base of the logarithm. Now listen, why are we going through this law? Because you are going to encounter questions that you're going to combine various more than one laws of logarithm to simplify the question. So all this law that we are discussing is very, very important. Do you understand? Okay, so we've looked at the change of base and we've also looked at the log of the base. Another important laws of logarithm is the inverse properties of logarithm. Let's say you have A raised to the power of log B base A. The answer to this question will be B. That means anytime what you have here is the same as the base of the logarithm, the answer will be what you have here. Do you understand? So let's say you have A raised to the power of log X base A. The answer here will be X. Do you understand? Anytime what you have here is the same as the base of this logarithm, you're going to have what the result will be the answer to this. Now let's say you have B raised to the power of log X squared base X. Do you know that this will also give me B raised to the power of 2 log X base X, right? So here I'm going to have B raised to the power of 2. Do you understand? This one that you see here cannot be regarded as inverse properties. Do you understand? Because what you have here is not the same as what you have here. Are you getting it? So now let's change it. Let's say you have B raised to the power of log X squared base B. You can see that what I have here is the same as what I have here. The result will be X squared. Do you understand? Okay. Let's look at another one. Let's say you have 5 raised to the power of log 6 base 5. Because 5 is here and the base of this logarithm is also 5. The result here will be 6. Do you understand? Okay, let's change it. Let's say you have let's say you have 6 raised to the power of log 10 base 6. The result here will be equals to 10 because what I have here is the same as the base of the logarithm. Do you understand? So let me quickly test you. What will this one be? Let's say you have e raised to the power of ln A. What will be the answer? The answer here will be A. Do you know the reason? Because ln A is equals to log A base E. Do you understand? And if you substitute the value of ln A as log A base E here, you're going to have e raised to the power of log A base E. Now, because what we have here is the same as the base of the logarithm, the result will be what? A. Do you understand? Okay, so what you have on the board here is called the inverse properties of logarithm. This one that you see here that I did, I just put it in the midst to help you to understand that you can have a question of this kind. And because the log of a power, the property that I use here is called the log of a power. The log of a power is the product of the power and the log. So these two multiply the logarithm. And because log x base x is 1, do you understand? The log of base, this law that we discussed, the log of the base. So because log x base x is 1, 2 times 1 will give me 2. So the result will be b raised to the power of 2. Do you understand? So this what you have on the board here is called the inverse properties of logarithm. Now, another important laws of logarithm that we are going to look at is the log of a product power. Let's say you have log a raised to the power of b times log c raised to the power of d. According to this law, do you know that if you have log a times c, this will be equals to log a plus log c, according to the product rule of logarithm. Do you know? Now we are having log a raised to the power of b times c raised to the power of d. This will be equals to log a raised to the power of b plus log c raised to the power of d. Do you know? Now, according to this law, the log of a power, if you have log a raised to the power of b, this will be equals to b multiplied by log a. Do you know? That is, if you have the log of a power, if your logarithm is raised to a power, the result will be the product of that power and the log. Do you know? Now, the same, I'm going to apply it to this and this. So therefore, here, I'm going to have log a raised to the power of b times c raised to the power of d will be equals to b multiplied by log a plus d multiplied by log c. Do you know? So, this law that you see here is called the log of a product power, okay? Now, let's look at the next law, which is the log of a quotient, the log of a quotient, quotient. The log of a quotient power. That is the next law that we are going to look at, okay? Now, listen. Okay, we are done with this. Let's look at this. According to this law, if you have log a raised to the power of b divided by log c raised to the power of d. Hello? If you have log a raised to the power of b divided by log c raised to the power of d, the answer here will be log a raised to the power of b minus log c raised to the power of d. Do you know? Now, you know that according to this law, the quotient rule of logarithm, if you have log a over c, this will be equals to log a minus log c. Do you know? Likewise, if you have log a raised to the power of b all over c raised to the power of d, you're going to have log a to the power of b minus log c to the power of d. So therefore, here, because the log of a power is the product of that power and the log, so I'm going to have b log a minus d log c. This law that you see here is called the log of a quotient power, okay? So we've talked about the log of a product power and the log of a quotient power. Another important law of logarithm that we are going to look at is the base power law. That is, if you have a logarithm, maybe log b base a raised to the power of, log b base a raised to the power of c, you can see that the base of this logarithm is raised to a power. The result of this kind of log will be the inverse of the power multiplied by the log. Okay, no, base a. Hello, it's simple. Anytime you have a logarithm whose base is raised to a power, the result will be the inverse of the base multiplied by the logarithm. So let's say you have log 5 base 3 raised to the power of 2. This will be equals to 1 over 2 multiplied by log 5 base 3. Do you get it? Okay, another one. Let's say you have log 6 base 7 raised to the power of 2. This will be equals to 1 over 2 multiplied by log 6 base 7. Anytime you have a logarithm whose base is raised to a power, the result will be the inverse of the power multiplied by the log. The inverse or the reciprocal of the power multiplied by the log. Do you understand it now? Okay, so now, This law that you see here is called the base power law. Now, let's look at the next law, which is the equality properties of logarithm. When do we say two log are equal? Let's say we have log A equals to log C. Log A is only equals to log C if A is equals to C. Are you getting it? So therefore, for these properties, if A is 5, that means C must also be 5. Do you understand? This law that you see here is called the equality properties of logarithm, okay? Now, the next law say the log of 1. What would be the, if you punch the log of 1 in your calculator, what are you going to have? The log of 1 will give you 0, okay? That is the next law, the log of 1. The log of 1. The log of 1 will be equals to 0, okay? So please kindly note all this law that we are discussing, okay? Please kindly note all the law. The 12th law of logarithm that we're going to talk about is the index law of logarithm. This law that you see on the board is one of the important laws that connect logarithm and indices. And in this law, we're going to be learning how to rewrite a logarithm form question back to index form. For example, let's say you have log y base x equals to z. Do you know that this one is in logarithmic form? You understand? What you have on the board is in logarithmic form. You can rewrite this in index form. That means this in index form will be x raised to the power of z will be equals to y. Okay? So let's say you have log y base x. This base that you see here will carry what you have here. Do you understand? And you are going to equate it to what you have here. That is what this law is all about. So that means if you have log A base b equals to c, this is in logarithmic form. If you want to rewrite this in index form, you are going to have b raised to the power of c equals to a. Are you getting it? Now, I want you to try this. Let's say you have log t base p equals to q. I want you to rewrite this in index form. Okay, pause this video, rewrite this in index form, then play it. The answers to this will be p raised to the power of q equals to t. That is the answer. Okay, now do you know the reason why log 1 is equals to 0? The reason why log 1, please pay attention. Log 1 base, maybe base 10, okay, is equals to 0. You know, I told you that anytime you have the log of a number that the base is not included, the base of that log is 10. Do you understand? So now, why is log 1 equals to 0? Let us check. If you want to rewrite this in index form, what are you going to have? The base is going to take this. Are you getting it? So I'm going to have 10 raised to the power of 0 equals to 1, right? Now, because according to the law of indices, if you raise a number, no matter how large or small the number is, you're going to have 0. So that means 10 raised to the power of 0. Oh, sorry. If you raise a number to the power of 0, you're going to have 1. That's what I'm trying to say. Now, that means 10 raised to the power of 0 will give me 1. That is why anytime you punch log 1 in your calculator, you're going to have 0. Okay? So, these properties that you see here is called the index law of logarithm. Okay? Now, let me give you another example. Let's say you have log z base p equals to t. I want you to rewrite this in index form. If you want to rewrite this in index form, you're going to have p raised to the power of t equals to z. Okay? Please master all this law. So in this class, we've talked about the product rule of logarithm, the quotient rule, the power rule, the change of base rule, the log of the base, the inverse properties of logarithm, the log of a product power, the log of a quotient power, the base power law, the equality properties of logarithm, the log of 1, and the index law. If you have any question as touching what we've learned in this class, let me know in the comment section, okay? So let's consider the question that we have on the board. We are looking at the index law of logarithm. We are asked to express the following in index form. The first question here is log 9 base 3 equals to 2. We want to change log 9 base 3 equals to 2 to index form. Don't forget that I told you that according to index laws of logarithm, if you have log y base x equals to z, if you want to change this to index form, This base will carry what you have here. So I'm going to have x raised to the power of z equals to, you're going to equate to what you have here, equals to y. X raised to the power of z equals to y. Do you understand? So that means if I want to change log 9 base 3 equals to 2 to index form, log 9 base 3 equals to 2 in index form. This base, which is 3, will carry this 2. So I'm going to have 3 raised to the power of 2 will be given. Do you get it? Because 3 raised to the power 2 is what? 3 times 3. And 3 times 3 is 9. Do you understand? So that is the solution to this question. In index form, this will be equals to 3 raised to the power of 2 equals to 9. Okay, let us look at the second question. We have log 64 base 2 equals to x. We are asked to change this to index form. For this, I'm going to have log 64 base 2 equals to x. In index form, I'm going to have 2 raised to the power of x equals to 64. Do you understand? So the answer to this is 2 raised to the power of x equals to 64. 2 raised to the power of x equals to 64. Now, let's now say you are asked to find the value of x. Hello? Do you know the goals of the question is to change all the expression from logarithmic form to index form, right? But now, let's now assume that the questioner proceed and said, solve for the value of the variable. For example, from this point, find the value of x. Do you know that 2 raised to the power of x equals to 64? 64 in index form can be written as 2 raised to the power of 5, right? 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, 32. Oh, 2 raised to the power 6. That is 2 raised to the power 6, right? So therefore, here I'm going to have 2 raised to the power of x equals to 2 raised to the power of 6. Hence, x will be equals to 6. Because now the base here and this base are equal. That means that their power will also be equal. So x equals to 6. Okay? Now, we have log p base 8 equals to q. We are asked to change this to index form. This will be equals to 8 raised to the power of q equals to p. Do you understand? Because this 8 will carry this. Now we have the fourth question. Log 10,000 base 10 equals to x. We are asked to change it to index form. Log 10,000, sorry. Log 10,000 base 10 equals to x. For this, I'm going to have 10 raised to the power of x equals to 10,000, right? Now, 10,000 can be written as 10 raised to the power of 3, right? Because 10 times 10 is 100. 100 times 10, 1,000. Oh, 10 raised to the power 4. So I'm going to have 10 raised to the power of x equals to 10 raised to the power of 4. So therefore, the value of x here will be equals to 4. Because now the base here are equal. That means the power will also be equal. So this in index form will be 10 raised to the power of x equals to 10,000. Okay? Now we have the next question, which is log 1 over 16 base 2 equals to negative 4. We are asked to change this to index form. The answers to this will be 2 raised to the power of negative 4 equals to 1 over 16. And this is true. This is true because if you have, listen to me, if you have a raised to the power of negative 1 will give me what? 1 over a, right? According to law of indices. By the way, if you want to learn more on indices, you can check the link in the description of this class. You're going to find the link there if you want to learn more on indices, okay? Because you see, indices and logarithm, they are related. Are you getting it? So now, if you have a raised to the power of negative 2, you're going to have 1 over a squared, right? Now, but we are having 2 raised to the power of negative 4. 2 raised to the power of negative 4 will be equals to 1 over 2 raised to the power of 4. And this will be 1 over 16, right? Yes. So therefore, you can see that 2 raised to the power of negative 4 is 1 over 16. And what we have at the right-hand side is also the same thing as 1 over 16. So that means that this law is very true. Are you getting it? This law is true. And the last question, we have log 3 base 27 equals to 1 over 3. We are asked to change this to index form. Here, I'm going to have 27 raised to the power of 1 over 3 equals to 3. Let us simplify 27 raised to the power of 1 over 3. 27 raised to the power 1 over 3 will be equals to square root of, third root, the third root of 27. And the third root of 27 will give me 3. Because 3 raised to the power of 3 will give me 27, right? 3 times 3, 9. 9 times 3, 27. So therefore, this is true. So anytime you are asked to change a logarithm form, a logarithm to an index form, all you have to do is that focus on the base and check what you have here. the base is going to carry what you have here, and you're going to equate it to what you have in this place. Do you understand? So if you have log t base p equals to z, what will be the answer in index form? That will be p raised to the power of z equals to t. I hope you understand. Okay, having learned the various laws of logarithm, now let us look at the application of all these laws. Okay, we are asked to evaluate the following without using tables or calculator. The first question says log 81 base 3. Okay, log 81 base 3. You can do this in two ways, you understand? Hello, you can solve this question in two ways. The first way is to write this using log of a power, you understand? You know, I taught you log of a power. That is, when you have the logarithm of a number, log a raised to the power of b, this will be equals to b log a, right? Yes, log a to the power of b is b log a. So, and you can also use the index form of logarithm, okay? So I'm going to solve this question using the using both ways. Are you getting it? And you're going to tell me the ways that you find easier. Are you getting it? So now let's go. For this, the first method. Now, do you know that the base here is what? Is 3, right? So I'm going to have log. Now, I want to write 81 as index of 3. 3 raised to the power of what will give me 81? That is 3 raised to the power of 4, right? 81 can be written as 3 raised to the power of 4. So I'm going to have, instead of 81, I'm going to have 3 raised to the power of 4, right? So, and the base here is also 3, so I'm going to have 3 here. Are you getting it? Now, according to this law, if you have log a raised to the power of b base c, right? This will be equals to b multiplied by log a base c. Okay, now I'm having log 3 base 3 raised to the power of 4. I'm going to have 4 log 3 base 3, right? Now, according to this law, if you have log a base a, this will be equals to what? 1. So therefore, log 3 base 3 will give me 1. So I'm going to have 4 multiplied by 1, which is equals to 4. Now, this method that you see here, the rules that I use is known as the log of a power. You understand? Now let us use the second law, the second method. The second method. The second method here, you set this logarithm equals to a letter. You understand? So I'm going to have let log 81 base 3 equals to any letter. Let's use a, right? So now let us write this logarithm in index form. Recall that I told you and I gave you this law. If you have log y base x equals to z in logarithmic form, it can be written in index form as x raised to the power of z equals to what? Y. So therefore, I'm going to write this in index form. So therefore, I'm going to have 3 raised to the power of a equals to what? 81, right? 3 raised to the power of a equals to, now, 81 can be written as 3 raised to the power of 4. So I'm going to have 3 raised to the power of 4. Now, because this base here is equal, that means the power will be equal. So therefore, a will be equals to 4. Do you understand? Okay, you can see that you can use any of the law. You are still going to have the same answer. Do you understand? That means that laws of logarithm, they are interwoven. You understand? They are interrelated. If you use any law, you are going to have the same answer. And the structure of a question will tell you the law that is applicable to the question. Do you understand? Okay, let's look at the second question. We have log 0.0625 base 4. We are asked to evaluate it without using calculator or mathematical table. Log 0.0625 base 4. Okay, now listen and listen carefully. Do you know that 0.0625 can be written as 625 all over 10,000? Do you know? It's just as if I change this to standard form. I'm going to have 1, 2, 3, 4. That is 625 times 10 raised to the power minus 4, right? And according to the law of indices, if you have 10 to the power of negative 4, it can be written as 1 over 10 raised to the power of 4, right? So I'm going to have multiply 625. 625 times 10 raised to the power 4. Okay, 625 times 1, that is 625. 10 raised to the power of 4 is 10,000. So that's how I have this. So for this, I'm going to have log, instead of 0.0625, I'm going to replace it with 625 all over 10,000. So I'm going to have 625 all over 10,000, okay? And the base is 4. Are you getting it? Now, if you reduce this fraction, you're going to have log 1 all over 16, and the base is 4. Are you getting it? Okay. Here, I'm going to have log 1 over 16 can be written as 16 raised to the power of negative 1, right? So I'm going to have 16 raised to the power of negative 1, and the base is what? Is 4. Now, 16 can be written as, 16 can be written as 4 raised to the power of 2, right? So I'm going to have log 4 raised to the power of 2 raised to the power of negative 1, and the base is 4. Are you getting it? Now, listen to me carefully. If you have, according to law of indices, I told you indices and logarithm, they are interwoven. Are you getting it? So, if you have a raised to the power of b raised to the power of c, this can be written as a raised to the power of b times c, right? So that means if I have 4 raised to the power of 2 raised to the power of negative 1, this can be written as 4 raised to the power of negative 2, because 2 times minus 1 will give me minus 2. Are you getting it? Okay, so for this, I'm going to have log 4 base 4, and the power will be what? Minus 2. Now, according to log of a power, if you have log a to the power of b, this will be equals to b multiplied by log a, right? So log 4 base 4 to the power of negative 2 will be minus 2 multiplied by log 4 base 4. Are you getting it? So log 4 base 4 will give me 1. So I'm going to have minus 2 times 1. Minus 2 times 1 will give me minus 2. So the simplified version of this will give is equals to minus 2. This method is called the log of a power method. Are you getting it? I just use the main properties or the main rules of logarithms I use here is log of a power. You can also use the index laws of logarithm to simplify this, just like we did in the previous example. Are you getting it? I mean, in the previous question. So let us also use the index laws of logarithm and see what you're going to have. Okay. Okay. If you want to use the index form of logarithm, the first thing is that you let log 0.0625 base 4 to be equals to a letter. Okay, so I'm going to have let log 0.0625 base 4 equals to p, any letter, Now, if you want to write this in index form, you're going to have 4 raised to the power of p equals to what? 0.0625, right? So I'm going to have 4 raised to the power of p equals to, now listen to me, 0.0625 can be written as 625 all over 10,000, right? So I'm going to have 4 raised to the power of p equals to 1 over 16. If you reduce this fraction to its lowest term, you're going to have 1 over 16. Now, if you change this to 1 over 16 can be written as 16 raised to the power of negative 1. And I'm going to have 4 raised to the power of p here. Okay? 4 raised to the power of p equals to 4 raised to the power of 2 raised to the power of negative 1, right? 4 raised to the power of p, 4 raised to the power of p equals to 4 raised to the power of negative 2. Now, because this base, they are equal, the power will also be equal. So therefore, p will be equals to negative 2. Now, because we've set log 0.0625 base 4 equals to p, that means the answer here will be negative 2, which is the same thing as what we got when we using the first method. Do you understand? You can see that the rules are interwoven. So we are done with that question. Okay, let's look at the third question. We have log 32 base 8. Log 32 base 8. I want you to try that question by yourself. Pause this video, try the question by yourself. When you are done, play the video to check whether you are correct or wrong. Okay? Okay. For this, please kindly pay attention, okay? Let's use the first method first. Now, we have log 32 base 8. You can see that the base here is what? Is 8. Now, what number can we raise 8 to that are going to have 32? You can see that there is no such number. Well, if there is, but we are going to that means it's going to be in fraction, but we are not in need of that. Are you getting it? So just pay attention and watch me. You know that 8 can be written as 2 raised to the power of 3, right? 8 can be written as 2 raised to the power of 3. Also, 32 can be written as 2 raised to the power of 5. Do you know? 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, 32. Do you know? Now, instead of 32 here, I'm going to replace that 2 raised to the power 5. And instead of 8, I'm going to replace that 2 raised to the power 3. Are you getting it? All I'm doing is that I want to make the log here and the number here and the number here to be the same, so that I can make use of the log of a base. You understand? Okay, please pay attention. So I'm going to have log 32. 32 is 2 raised to the power 5. I'm going to have 2 raised to the power of 5. Now, base 8. 8 can be written as 2 raised to the power 3. So I'm going to have 2 raised to the power of 3. I'm sorry, I'm coming. 8 can be written as 2 raised to the power of 3. So I'm going to have 2 raised to the power of 3 here, and then 2 raised to the power of 5 here. Okay? Now, recall that if you have the base power law that I taught you, if you have log A base B raised to the power of C, log A base B raised to the power of C, that is, now you can see that the base is carrying power. The result will be 1 over C multiplied by log A base B, right? Now, because the base here is carrying power, I'm going to have 1 over 3 log 2 raised to the power of 5 base 2. That is, if you have when the base of a logarithm has a power, the result will be the inverse of the power multiplied by the log. Do you understand? Now, the power of the base here is what? Is 3. So I have 1 over 3 log 2 raised to the power of 5 base 2. Do you get it now? Okay. Now, according to this law again, if you have log A raised to the power of B, this will be equals to B multiplied by log A, right? So now this 5 will multiply this fraction. I'm going to have 5 multiplied by 1 over 3 log 2 base 2. Do you understand? Because now this 5 is multiplying this. Hello? So for this, I'm going to have 5 all over 3 log 2 base 2. Log 2 base 2 is what? Is 1. So because logarithm of a number to the same base is 1. So I'm going to have 5 over 3 times 1. This is equals to 5 over 3, which is the answer. Okay, now let's look at the second method. The second method. Okay, now you will discover that the first method, I combine various laws of logarithm before I arrive at my question. So you can see that you cannot know one law and ignore the other. Like, you cannot decide to just focus on one law and ignore the other. All the laws are interwoven, you understand? And just like this question, you can be given question that you are going to combine more than 2 laws to solve the question. Are you getting it? For example, here I use the base log power. Here I use log of a power. Here I use log of the same base. You can see that. Are you getting it? So make sure you master all the law. Now, the second method, let log 32 base 8, sorry. Let log 32 base 8 equals to a letter. Let it be equals to B. Are you getting it? Now, if you want to write this in index form, you are going to have 8 raised to the power of B equals to 32, right? Are you getting it? Okay. 8 can be written as 2 raised to the power of 3. So I'm going to have 2 raised to the power of 3 raised to the power of B equals to, now, 32 can be written as 2 raised to the power of 5. Are you getting it? So for this, according to this law, A raised to the power of B raised to the power of C, I'm going to have A raised to the power of B times C, right? So 2 raised to the power of 3 raised to the power of B can be written as 2 raised to the power of 3B. This will be equals to 2 raised to the power of 5. Now, because the base here are equal, I can equate the power. So I'm going to have 3B equals to 5, right? So divide by 3, this over 3 and this over 3. B equals to 5 over 3, which is also the same answer that we have here. Now, because we've let log 32 base 8 equals to B, so therefore, and B equals to 5 over 3, that means the answer here will be 5 over 3. So the answer to this question is 5 over 3. Do you understand? Let's look at question number 4. We have log 0.5 base 32. Okay, I'm still going to solve this question using both methods. Do you understand? Okay, let's start with the first method. Don't forget that 0.5 can be written as 1 over 2. So I'm going to have log 1 over 2 base 32, right? Now, 32 can be written as 2 raised to the power of 5. So I'm going to have log 1 over 2 base 2 raised to the power of 5. Now you can see that the base is now carrying power, which is 5. So I'm going to have 1 over 5 multiplied by log 1 over 2 base 2. Do you know? Now 1 over 2 can be written as 2 raised to the power of negative 1. So I'm going to have 1 over 5 multiplied by log 2 raised to the power of negative 1 base 2, right? Now, because the log of a power is the product of that power and the log, so this negative 1 is going to multiply the logarithm. So I'm going to have minus 1 multiplied by 1 over 5 multiplied by log 2 base 2, okay? Minus 1 times 1 over 5, that is minus 1 all over 5, and log 2 base 2 is what? Is 1. So I'm going to have multiplied by 1. The answer is negative 1 over 5, okay? Now let us look at the second law and check. Maybe we are going to have negative 1 over 5 as the answer. So for this, I'm going to have let log 0.5 base 32 equals to any letter, maybe x, okay? Now, let us write this in index form. I'm going to have 32 raised to the power of x equals to 0.5, right? 32 raised to the power of x equals to 1 over 2 because 0.5 can be written as 1 over 2. Do you get it? Okay. Now, 32 can be written as 2 to the power of 5. So I'm going to have 2 raised to the power of 5 raised to the power of x equals to, now 1 over 2 can be written as 2 raised to the power of negative 1. So I'm going to have 2 raised to the power of negative 1, right? Now for this, don't forget that if you have a raised to the power of b raised to the power of c, this will be equals to a raised to the power of bc, right? So I'm going to have 2 raised to the power of 5x because 5 will multiply x just like b multiplies c. Do you understand? So this will be equals to 2 raised to the power of negative 1. Because the base are the same, that means that the power will also be the same. So I'm going to have, I can equate the power. Do you understand? That's what I'm trying to say. The base are the same. I can now equate the power. So I'm going to have 5 times x equals to negative 1. To get the value of x, I'm going to divide both sides by 5. So I'm going to have this over 5 and this over 5. So x is equals to negative 1 all over 5. Okay? Let me write it very well. Negative 1 over 5. So the answer here is equals to negative 1 all over 5. That is the answer, okay? So what of this? Log 128 base 0.25. Okay, let me just attempt the solution here. Log 128 base 0.25. Okay, how can we solve this question? Well, let us use the second method. Let log 128 base 0.225 equals to a letter, maybe x, right? So I'm going to have 0.25 raised to the power of x is equals to 128. All I did here was that I changed this to index form, right? Now, 0.25 can be written as 1 over 4. Do you know? So I'm going to have 1 over 4 raised to the power of x is equals to, now, can we raise 4 to a number that is going to give us 128? Let us try. 4 raised to the power of 3 will not give us 128. 4 raised to the power of 4 will not give us 128. So let us take it step by step. We're going to have 128 here, right? Here I'm going to have 4 raised to the power of negative 1 raised to the power of x equals to, now, 128. Since I cannot raise it to the power of 4, I cannot raise 4 to a number that is going to give me 128. So let us think of 2. 2 raised to the power of what will give us 128? That is 2 raised to the power of 7, right? So I'm going to have, instead of 128, I'm going to have 2 raised to the power of 7. Now, please listen and listen carefully. 4 raised to the power of negative 1 can be written as 2 raised to the power of negative 2, right? Let me do it here. 4 raised to the power of negative 1. 2 raised to the power of 2 raised to the power of negative 1, right? 2 raised to the power of negative 2 because 2 will multiply negative 1 according to the law of indices, right? So I'm going to have 2 raised to the power of negative 2 raised to the power of x equals to 2 raised to the power of 7, right? So I'm going to have 2 raised to the power of negative 2x equals to 2 raised to the power of 7. So now, because the base are equal, the power, I can equate it. So I'm going to have negative 2x equals to 7. To get the value of x, I'm going to divide both sides by negative 2, right? So for this, I'm going to have this all over negative 2 and this over negative 2. So the value of x will be equals to negative 7 all over 2, which is the answer to this question. So here I'm going to have negative 7 all over 2. That is the answer. Do you understand? If you do understand, kindly listen to the explanation again, okay? So let us proceed to the next question. By the way, you can also make use of the first method to solve this question. You are still going to arrive at this answer. Do you understand? Okay, now let's evaluate this without using calculator. We are asked to solve log square root of 128 base 2 root 2. Okay, let's use the first method. Don't forget that square root of 128 can be written as square root of 128 can be written as square root of 64 times 2, right? That will be what? 8 root 2. Do you get it? So here I'm going to have log 8 root 2 base 2 root 2. Do you understand? Okay? Please pay attention. Do you know that 2 root 2 is equals to 2 multiplied by the square root of 2, right? And also 8 root 2 is equals to 8 multiplied by square root of 2, right? Okay, for this I'm going to have 2 multiplied by 2 raised to the power of 1 over 2, right? Now listen to me carefully. The power of this 2 is what? 1, right? So I'm going to have 2 raised to the power of 1 plus 1 over 2, according to the law of indices. So this will give me 2 raised to the power of 3 over 2. Okay, let's check this. Do you know that 8 can be written as 2 raised to the power of 3? So I'm going to have 2 raised to the power of 3 times 2 raised to the power of 1 over 2, because the square root of 2 will give me, the square root of 2 is 2 raised to the power of half. So here I'm going to have 2 raised to the power of 3 plus 1 over 2. Okay, this will be equals to 2 raised to the power of 7 over 2. Do you understand? Okay, now instead of 8 root 2, I'm going to replace it at 7 over 2. And instead of 2 root 2, I'm going to replace it at 2 raised to the power of 3 over 2. Sorry. Instead of 8 root 2 here, I'm going to replace it as 2 raised to the power of 7 over 2. So I'm going to have log 2 raised to the power of 7 over 2 base 2 raised to the power of 3 over 2. Do you get it? Now, I taught you the base power law. That is, when you have a logarithm that the base is raised to a power, you are going to have the inverse of 3 over 2. That is what? 2 over 3 log 2 raised to the power of 7 over 2 base 2. Do you know what I did? There is a law that I taught you, that if you have a log a raised to the power log a base b raised to the power of c will be equals to 1 over c log a base b, right? That is, if you have a logarithm whose base is raised to a power, the result will be the inverse of that power which the base is raised to, multiplied by the logarithm. So the same thing I did here. The inverse of 3 over 2 is what? 2 over 3. So I multiply 2 over 3 by the logarithm. Now there is another law that states that if you have the log of a power, that is, the power of this logarithm now is what? 7 over 2, right? The log of a power is the product of the power and the log. So that means that this 7 over 2 will multiply 2 over 3, right? So I'm going to have 7 over 2 multiplied by 2 over 3 log 2 base 2. Do you get it? If you didn't understand, listen to the explanation again. It's simple. All I use here are the laws of logarithm. There is this law of logarithm. If you have log a to the power of b, it will equals to what? B log a, right? So that means that log 2 base 2 to the power of 7 over 2 will be equals to 7 over 2 times 2 over 3 log 2 base 2. Do you understand? So for this, log 2 base 2 is 1. So I'm going to have 2 here, 7 over 3 multiplied by 1, which is 7 over 3. The answer here is 7 over 3. 7 over 3. Okay? So this method that you see here is the first method. You can also use the second method to solve the question. Are you getting it? That is, you're going to set this log to be equals to a letter, then you change it to index form, then you proceed with your solution. Trust you understand everything that we discussed in this class. If you didn't understand, please let me know in the comment section. And also, if you understand, kindly drop comments. Are you getting it? I need your review as touching this class. So make sure you give me feedback. And also, please kindly hit the subscribe button, click on the like button, and also share the video to your friends. Evaluate the following without using calculator or four-figure table. Let's start with the first question. Log 16 base 2. To solve this question, log 16 base 2, just like the previous example that we did, you can approach this question using the index form of logarithm, or you can also use the base power, you understand? Or the log of a power. Are you getting what I'm trying to say? Let's consider the question that we have on the board. We are asked to evaluate the following without using calculator or four-figure table. The first question we have, log 16 base 2. You can approach this question in two ways. The first way is to use the index form of logarithm, just like we did in the previous example, or you make use of the log of a power, you understand? So for this, I'm going to make use of the index form of logarithm. And to do this, I'm going to set this logarithm equals to a letter, you understand? So I'm going to have let log 16 base 2 equals to x, okay? So now I'm going to rewrite this logarithm. I'm going to rewrite this in index form. Do you understand? So I'm going to have 2 raised to the power of x equals to 16. Are you getting it? Now don't forget that 16 can be written as 2 raised to the power of 4. Do you understand? So I'm going to have 2 raised to the power of x equals to 2 raised to the power of 4. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. Right? So now, because the base here are equal, that means I can set the power to be equal. You understand? So here, x will be equals to 4. Do you understand? This one that you see here, this method is called the index form of logarithm. That is, you set the logarithm equals to a letter, and then you rewrite the expression in you rewrite the logarithmic equation, you rewrite it in index form. Do you understand? Okay, now let's look at the second question. We have log 10,000 base 10. Okay, I'm going to solve this question using the second method, which is the log of a power. Are you getting it? Log 10,000 base 10. Okay, now the base here is 10. So I'm going to write 10,000 as an index of 10. Okay, now 10 times 10 will give me 100. 100 times 10 will give me 1,000. 1,000 times 10 will give me 10,000. Are you getting it? So that means that 10 raised to the power of 4 will give me 10,000, right? That is 10,000 equals to 10 times 10, 100 times 10, 1,000 times 10, that is what? 10,000. So therefore, I'm going to have, instead of 10,000, I'm going to have log 10 raised to the power of 4, because it is 4 10 that I multiply together to give me 10,000. So I'm going to have log 10 raised to the power of 4 base 10, okay? Now, according to this law, if you have log a raised to the power of b base c, this will be equals to b multiplied by log a base c. So log 10 base 10 to the power of 4 will be equals to 4 multiplied by log 10 base 10. And because this base is equals to the log, so I'm going to have 4 times 1. 4 times 1 is what? 4. So I'm going to have this will be equals to 4, which is the answer to the second question. Okay, you can see the first question we have 4. The second question as well, we have 4. Okay, let's look at the third question. This is 4. This is also 4. The third question we have log 81 base 9. Okay, log 81 base 9. Log 81 base 9. Now, 81 can be written as 9 raised to the power of 2. Hello? Anytime you are confronted with this kind of question, kindly pay attention to the base. Do you understand? Now, 81 can be written as 9 raised to the power of 2. So I'm going to have log 9 raised to the power of 2 base 9. Are you getting it? Now, according to log of a power, if you have the logarithm of a power, you're going to have the result will be the product of the power and the log. Do you understand? Now, we have the logarithm of 9 to the base of 9 raised to the power of 2. So the result here will be 2 multiplied by the logarithm of 9 base 9. Do you understand? And the log of the base, remember that law. The log of the same base will give us what? 1. So here I'm going to have 2 multiplied by 1, which is what? 2. So the result here will be equals to 2. Okay, let's look at the fourth question. We have log 49 base 7. I want to do something. Pause this video, then attempt this question. When you are done, play the video to check whether your answer is correct. Do you understand? Okay, now let's attempt this. Log 49 base 7. Now, 49 can be written as 7 raised to the power of 2. Do you know? So I'm going to have log 7 raised to the power of 2 base 7. Now, according to this law, this base is 7, not 2. Here, I'm going to have 2 multiplied by log 7 base 7. That is 2 multiplied by 1, which is equals to what? 2. So you can see that the answer here is also 2. So we are done with the first, second, third, and fourth question. Okay, let's look at the next question, which is log 625 base 5. Okay, if you encounter this question, how are you going to handle it? Are you going to use the index form, or you're going to proceed with the log of a power? Here, I'm going to make use of the log of a power. You understand? You can use any method, okay? You can use any method. So let's proceed. I have log 625 base 5, okay? Now, 625, listen, focus on this base. The base here is what? 5. So I'm going to rewrite 625 as an index of 5. So 5 times 5 will give me 25. 25 times 5 will give me 125. 125 times 5 will give me 625. So that means that I have to multiply 5 4 times to give me 625, right? So I'm going to have log 625 is equals to 5 times 5 times 5 times 5. This is equals to 5 raised to the power of 4, right? So I'm going to have 5 raised to the power of 4 base 5. Okay? So here I'm going to have 4 multiplied by log 5 base 5. That is 4 times 1. 4 times 1 is what? 4. So the answer here is 4. Do you understand? Okay. Let's look at the next question, which is log 3 base 9. Okay? Log 3 base 9. Let me erase this. Log 3 base 9. Now, here, you can make use of two methods as well. You can see that the base here is even greater than the logarithm itself. The base of the logarithm is 9. Why the logarithm of the number that we're taking the logarithm is what? Is 3. So now, you can make use of the index form of logarithm, or you can use the base power law that I taught you when we start this class. Okay? Now, according to base power law, do you know that 9 can be written as 3 raised to the power of 2? Do you know? So I'm going to have log 3 base 9. Now, I'm going to rewrite the 9 as 3 raised to the power of 2. So I'm going to have 3 raised to the power of 2. Are you getting it? Now, according to base law power, now, the power of the base is 2. And anytime we have the logarithm of the number whose base has a power, the result will be the inverse of the power multiplied by the logarithm. Do you understand? So here I'm going to have 1 over 2, because the inverse of 2 is what? 1 over 2 multiplied by the logarithm. The logarithm is 3 times log 3 base 3. Are you getting it? The inverse of the power. Inverse of 2 is 1 over 2, right? And the logarithm itself is log 3, and the base 3 is still 3. Now, log 3 base 3 is 1. So I'm going to have 1 over 2 multiplied by 1. This is equals to 1 over 2. Do you understand? Okay. Now, we have the next question, which is, the answer here is 1 over 2. Now, we have the last question for this. Log 4 base 32. Attempt this question by yourself. When you are done, then you can play the video to check whether your answer is correct. Do you understand? Okay, now let's go. Okay, let us proceed to the next question. We have log 4 base 32. Now, how do you solve this question if you encounter this kind of question in exam? Well, to do that, You can make use of the index laws of logarithm, and you can also use the log of a power, and at the same time you can make use of the base power law. Are you getting it? So if you want to use the log of a power and the base power law, you are going to combine those two laws to solve this question. Though I'm going to solve the question using the two methods. Do you understand? I'm going to use the index laws of logarithm, and also I'm going to use the combination of the log of a power and the base power law. So I want you to pay attention, okay? So now we have, let's look at the first method, which is the index power. I mean index form of logarithm. Okay, we have log 4 base 32. Now, the first step is that you have to set this logarithm, you have to set it equals to a letter. You understand? So I'm going to have let log 4 base 32 equals to a letter, which is p. You can use any letter, okay? Now, I'm going to rewrite this in index form. So I'm going to have 32 raised to the power of p equals to 4. Are you getting it? Now, do not forget that 32 can be written as 2 raised to the power of 5. Do you know? 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. Do you know? So I'm going to have 2 raised to the power of 5 raised to the power of p equals to, now 4 can be written as 2 raised to the power of 2. Do you know? So I'm going to have, instead of 4, I'm going to have 2 raised to the power of 2. Okay? Now, according to the law of indices, this 5 will multiply this p. So I'm going to have 2 raised to the power of 5p. This will be equals to 2 raised to the power of 2. Okay? Now, because the base are now equal, I can set the power to be equal. You understand? I can equate the power because the base are now equal. So I'm going to have 5p equals to 2. Okay? To get the value of p, what are you going to do? So I'm going to divide both sides by 5. So p will be equals to 5 over 2. Now, because I said let log 4 base 32, let it be equals to p. So the value of this logarithm is 5 over 2. Okay? Now, I'm going to make use of the second method. Peradventure, if you missed, if you didn't understand in the previous examples I did, you can learn it now. Okay? Now, the second method. In this second method, we are going to be combining two laws, the log of a power and the base power law. So now we have log 4 base 32, right? Okay. Now 32 can be written as 2 raised to the power of 5, right? So I'm going to have log, also 4 can be written as 2 raised to the power of 2. So I'm going to have log 2 raised to the power of 2 base 2 raised to the power of 5. Are you getting it? 2 raised to the power of 5 is 32. Okay, now according to base power law, if you have a logarithm whose base has a power, the result will be the inverse of the power multiplied by the logarithm. Now, the power here is 5. Inverse of 5 is 1 over 5. So I'm going to have 1 over 5 multiplied by log 2 raised to the power of 2 base 2 now. Are you getting it? The power here, as the power which is 5, is this. Are you getting it? It is a law. Now, and according to log of a power, when you log it, when you have a logarithm that is carrying a power, the result will be the product of the power and the logarithm. Do you know? So for this, I'm going to have 2 multiplied by 1 over 5 log, which is this is the power. The power will multiply this. So I'm going to have 2 times 1 over 5 log 2 base 2, right? So I'm going to have 2 over 5 log 2 base 2. Log 2 base 2 is what? Is 1. Because the logarithm of a number to the same base is 1. So I'm going to have 2 over 5 times 1, which is 2 over 5. Here is 2 over 5, okay? Now, oh, sorry. There is a little mistake here. This will be 2 over 5. 2 over 5. And this also should be 2 over 5. 2 over 5. Sorry. You know, when we if you divide both sides by 5, you're going to have p equals to 2 over 5. You understand? And I made a slight mistake here. So you can see that whether you use this method or this method, you must have the same answer if your approach is correct. Do you understand? Okay, so let's look at more questions on logarithm. We are asked to evaluate the following without using calculator or 4-figure table. The first question we have log 1 over 64 base 0.5. Okay, log 1 over 64 base 0.5. Okay, now the first thing that I would like you to understand is that 0.5 can be written as 1 over 2. Do you know? And also 1 over 2 can be written as 2 raised to the power of negative 1. Are you getting it? Also, 64, hello, 64 can be written as 1 over, okay, 64 can be written as 2 raised to the power of 6, right? Because 2 times 2 times 2, that is 8. 8 times 2, 16. 16 times 2, 32. 32 times 2, that is 64, right? So, and also, if it is 1 over 64 that we need, I'm going to have 1 over 64 will be equals to 1 over 2 raised to the power of 6. And also, according to the law of indices, 1 over 2 raised to the power of 6 will be 2 raised to the power of negative 6. Do you understand? Okay, so let us replace 1 over 64 as 2 raised to the power of negative 6 and also 0.5 as 2 raised to the power of negative 1. So the logarithm becomes log 2 raised to the power of negative 6 base 2 raised to the power of negative 1, right? Now, according to the base power law, because the power now is raised to the power of negative 1, I'm going to multiply this log by the inverse of the power of the base. Do you understand? So the base power is negative 1. So I'm going to have 1 over negative 1. 1 over negative 1 is still the same thing as negative 1. Do you know? So I'm going to have negative 1 log 2 raised to the power of negative 6 base 2. Now, according to the log of a power is the product of the power and the log. This logarithm is now raised to a power of negative 6. So I'm going to multiply the logarithm by negative 6, right? So I'm going to have negative 1 multiplied by negative 6 multiplied by log 2 base 2, right? Negative 1 times negative 6, that is 6, right? So I'm going to have 6 multiplied by, now logarithm of a number to the same base is what? Is 1. So log 2 base 2 will give me 1. So here I'm going to have 6 times 1. 6 times 1 is 6. Okay? You can use another law. You can use another method. Okay? You can use the index form of logarithm. You understand? You have to rewrite this logarithm in index form. And the first step is that you have to set this logarithm equals to a letter. Okay? So let log 1 over 64 base 0.5 equals to x, right? Now, we want to rewrite this in index form. This 0.5, it will become 0.5 raised to the power of x equals to what? 1 over 64, right? So 0.5 is 1 over 2, right? So I'm going to have 1 over 2 raised to the power of x is equals to 1 over 64. Are you getting it? Okay. 2 raised to the power of negative 1 is also the same thing as what? 1 over 2. So 1 over 2 is still the same thing as this. And also 1 over 64 is also the same thing as 1 over 2 raised to the power of 6, right? So I'm going to have 2 raised to the power of negative x is equals to 2 raised to the power of negative 6, right? Now, because the base are now the same, I can equate their power. So I'm going to have negative x equals to negative 6. Divide both by negative 1. This over negative 1. So x is equals to 6. Are you getting it? So you can see that we arrive at the same answer. So therefore, since I said that this logarithm equals to x, so therefore the answer here will be 6. Okay? So that is the solution to the first question. Okay, let's proceed to the second question. We have log 1 over 81 base 3. Log 1 over 81 base 3. Don't forget that 81 can be written as 3 raised to the power of 4, right? So this logarithm, I'm going to have log 1 over 3 raised to the power of 4 base 3, right? Okay, 1 over 3 raised to the power of 4 can be written as 3 raised to the power of negative 4. So I'm going to have log 3 raised to the power of negative 4 base 3, right? Now, according to this rule, the log of a power is the product of the power and the log. So I'm going to have minus 4 multiplied by log 3 base 3. Okay, the logarithm of a number to the same base is 1. So I'm going to have minus 4 times 1. Minus 4 times 1 is minus 4. So the answer to the second question is minus 4. Are you getting it? Okay, let's move to the third question. In fact, this question, I would like you to attempt it by yourself. When you are done, then I'm going to show you the solution, okay? Because now we are not requested. Let's assume that you are not using calculator, okay? Don't make use of a calculator, okay? Attempt the question by yourself. When you are done, then play this video to check whether your solution is correct, okay? Okay, let us simplify this logarithm without using calculator. Log 2.197 base 1.3. The first thing that I want to do is this. 2.197, we write it in standard form. This will be equals to 2197 times 10 raised to the power of negative 3, right? So I'm going to have 2197 all over 10 raised to the power of 3. And 10 raised to the power of 3 is what? 1000. So I'm going to have 2197 all over 1000, right? Okay, now the base is 1.3. 1.3 equals to 13 all over 10. Do you know? You know, if you rewrite this in standard form, you're going to have 13 times 10 raised to the power negative 1. And 10 raised to the power negative 1 is what? Is 1 over 10, you know? 13 times 10 raised to the power negative 1. 13 times 1 over 10, which will give us this, okay? Now, let us substitute what we have here into all this. So I'm going to have log, instead of 2.197, I'm going to have 2197 all over 10, okay, 1000, sorry, all over 1000, divided by 13 all over 10. Are you getting it? Okay. So please pay attention. The base here is 13 over 10. So I'm going to rewrite this as the index of 13 over 10. So 2197, hello, 2197 can be written as 13 times 13 times 13. So that will be 13 raised to the power of 3, right? Also, 1000 can be written as 10 times 10 times 10. That is 10 raised to the power of 3. Okay, so for this, I'm going to have 13 raised to the power of 3 all over 10 raised to the power of 3 base 13 over 10. Are you getting it? Okay, now listen. If you have A over B all over C over B, this can be written as A over B raised to the power of what? B. I mean A over C, sorry. A over C raised to the power of B. Do you understand? Take note of this. If you have the quotient of the same power, it can be written as the quotient of those numbers taking a single power. So I can write A raised to the power of B divided by C raised to the power of B as A over C to the power of B, okay? So the same law I'm going to use here. 13 raised to the power of 3 divided by 10 raised to the power of 3 can be written as log 13 over 10 raised to the power of 3, okay? And the base is 13 over 10. Are you getting it? Now, according to the log of a power, the power of this logarithm now is what? Is 3. So I'm going to have 3 multiplied by log 13 all over 10 base 13 all over 10, okay? Now, log 13 over 10 base 13 over 10 is what? 1. So I'm going to have 3 times 1. The answer is what? 3. So the result of this answer is 3. Do you understand? Okay, let's look at the next question. We have log 0.2 base 625. Okay, please kindly pay attention to this question. I want to pay attention because I'm going to ask you a question. If you come across this kind of question in exam, what are you going to think about? The base here is by far greater than the logarithm of the number that we are taking. The logarithm of the number that we are taking the logarithm is 0.2. Now the base is what? 625. Okay, 0.2 can be written as 2 times 10 raised to the power of negative 1, right? So that will be what? 2 times 1 over 10. That is 2 over 10. And 2 over 10 is what? 2 over 10 is 1 over 5, you know? 1 over 5. So I'm going to rewrite 0.2 as 1 over 5. So here I'm going to have log 1 over 5 base 625. Okay, now we can write 625 as the index of 5. Are you getting it? So how many 5 can I multiply together to give me 625? 5 times 5, 25, times 5, 125, times 5, 625. So this will be 5 raised to the power of 4, right? So here I'm going to have log 1 over 5 base 5 raised to the power of 4. Now, according to the base power law, if you have if you have a logarithm whose base has a power, the result will be the inverse of the power multiplied by the logarithm. So I'm going to have log 1 over 5 base 5 here. Do you understand? Now, 1 over 5 can be written as 5 raised to the power negative 1. So I'm going to have 1 over 4 multiplied by log 5 raised to the power of negative 1 base 5. Okay, here I'm going to apply the log of a power. You understand? The log of a power is the product of the power and the log. Now, the power of this logarithm now is negative 1. So I'm going to multiply this logarithm by negative 1. Do you understand? So I'm going to have negative 1 all over 4 log 5 base 5, because this power now has multiplied the logarithm. So log 5 base 5 will give me 1. Are you getting it? So I'm going to have negative 1 over 4 multiplied by 1. This is equals to negative 1 over 4. Okay, this method that you see here, you can also use another method to solve this question. That is index. Like, you can rewrite this logarithm in index form and then you solve it. Okay, and that is the method I want to show you now. So pay attention. Though I used the method in the previous example. In the previous question that I did, I used the method. So if you still don't get the method, you can get it now. Okay. Now we are asked to solve this question. The first step is that you can let log 0.2 base 625 equals to a letter, maybe x. Are you getting it? Now you will write this logarithm in index form. And if you want to write this in index form, you're going to have 0.2 equals to 625 raised to the power of x, right? Because the base the base here is going to carry what you have here, and you're going to equate it to what you have here. Do you understand? Okay. Now 0.2 can be written as 1 over 10, right? No, 1 over 5, sorry. So I'm going to have 1 over 5 equals to 625 raised to the power of x. 1 over 5 can be written as 5 raised to the power of negative 1. So I'm going to have 5 raised to the power of negative 1 equals to, now 625 can be written as 5 raised to the power 4, because 5 times 5 is 25. 25 times 5 is 125. 125 times 5 will give you 625. So I'm going to have 5 raised to the power of 4 raised to the power of x, right? So for this, I'm going to have 5 raised to the power of negative 1 equals to 5 raised to the power of 4x. Now, because these base are now equal, I can equate the power. So I'm going to set negative 1 equals to 4x. So I'm going to have negative 1 equals to 4x here. To get the value of x, I'm going to divide both sides by 4. So x is equals to negative 1 over 4, which is the same answer as we got using the first method. That's the same answer that we get using the first method. So that's the solution to that question. We have log square root of 512 base 4 root 2. Okay. Log square root of 512 base 4 root 2. Now, listen to me carefully. The first thing I want to do now is that don't forget that square root of 512 is going to be square root of 256 times 2, right? And this will give me square root of 256 times square root of 2. So I'm going to have square root of 256 is 16. So I'm going to have 16 times root 2. That is 16 root 2, right? I've already expressed this in its lowest term. So for this, I'm going to have log 16 root 2 base 4 root 2, right? Okay. Now, don't forget that 16 root 2 can be written as 4 raised to the power of 2 multiplied by root 2, right? Also, 4 raised to the power of 2 can be written as 2 raised to the power of 2 raised to the power of 2 times root 2. Do you know that 4 can be written as 2 raised to the power of 2? Are you getting it? So I'm going to have 2 raised to the power of 4 times root 2. Root 2 can be written as 2 raised to the power of 1 over 2, right? And according to the law of indices, a raised to the power of b times a raised to the power of c equals to a raised to the power of b plus c. So 2 raised to the power of 4 times 2 raised to the power of 1 over 2 can be written as 2 raised to the power of 4 plus 1 over 2. Okay? Take the LCM. This will give me 2 raised to the power of 8. 2 raised to the power of 9 plus 9 over 2. Do you understand? So that's it. Now, for the 4 root 2, please pay attention. 4 root 2 can be written as 2 raised to the power of, 4 root 2 can be written as 2 raised to the power of 2 times 2 raised to the power of 1 over 2. Because root 2 now is what? 1 over 2. Do you know? 4 is 2 raised to the power of 2. Square root of 2 is 2 raised to the power of 1 over 2, right? So I'm going to have 2 raised to the power of, now, sum their power. 2 plus 1 over 2. That is 5 over 2. 5 over 2. So I'm going to replace 16 root 2 as 2 raised to the power of 9 over 2. And also 4 root 2 as 2 raised to the power of 5 over 2. Okay, so I'm going to have logarithm of 2 raised to the power of 9 over 2 base 2 raised to the power of 5 over 2. Okay, Now, the base here now has power, you understand? So, and anytime we have the base of a logarithm that has power, the result will be the inverse of the power multiplied by the logarithm, you understand? The power of the base here is 5 over 2. So, what is the inverse of 5 over 2? Inverse of 5 over 2 is 2 over 5. So, I'm going to have 2 all over 5 multiplied by log, okay? Multiply log 2 raised to the power of 9 over 2 base 2. Now, the power has come here, and we now have the inverse of that power. That is 2 over 5, right? Now, 9 over 2. 9 over 2 is the power of the logarithm. Now, anytime you have the log of a power, that will be the product of the power and the log. Hence, this 9 is going to multiply this 2 over 5. I'm going to have 9 over 2. Sorry, this 9 over 2 is going to multiply all the log. 9 over 2 times 2 over 5 multiplied by log 2 base 2, right? This 2 will cancel this 2. I'm going to have 9 over 5 times log 2 base 2 is 1. So I'm going to have times 1. This will give me 9 over 5, right? Okay. You can solve this in using another method. Hello? That second method that I taught you, you can solve this question using that method, okay? You are still going to have an accurate answer. And that is the method I want to use now. So pay attention, okay? Okay. Now, we have log. I'm very sure you understand I got there. So now let's start from here. Let log 16 root 2 be equals to a letter. You understand? Or let me start from here. Let log square root of 512 base 4 root 2 be equals to x. Okay. Now let us write this in index form. I'm going to have 4 root 2 raised to the power of x equals to square root of 512, right? Now, square root of 512 is what? 16 root 2. So I'm going to have 4 raised to the power of, 4 root 2 raised to the power of x equals to 16 root 2. Do you get it? Okay. Now, I want you to pay attention here. Do you know that 4 root 2 can be written as 2 raised to the power of 2 multiplied by 2 raised to the power of 1 over 2 raised to the power of x equals to, now 16 can be written as 2 raised to the power of 4 multiplied by 2. Now, root 2 can be written as 2 raised to the power 1 over 2, right? Are you getting it? Now, 2 raised to the power of 2 multiplied by 2 raised to the power 1 over 2 is 2 raised to the power of 5 over 2. Do you understand? Okay, and also 2 raised to the power of 4 multiplied by 2 raised to the power of 1 over 2 is 2 raised to the power of 9 over 2, right? Now, 2 raised to the power of 5x all over 2 equals to 2 raised to the power of 9 over 2. So now, because the base are equal, I can set the power to be equal. So I'm going to have 5x all over 2 equals to 9 over 2. Do you understand? Okay, the goal is to find the value of x. So I'm going to divide both sides by 5 over 2 because now I'm having 5x all over 2 equals to 9 all over 2. So x is equals to, multiply both sides by 2 over 5, this over, and also this times 2 over 5. So this will cancel this. So I'm going to have x equals to 9 over 2 times 2 over 5. X equals to 9 over 5, which is the value of x. Now, because I've already set this logarithm equals to x, so the value will be 9 over 5, which is the answer that we got here. Do you understand? So both methods are they are mathematically correct. Okay, let's proceed to the next question. We have log 0.0004 base 50. Okay, log 0.0004 base 50. Now, 0.0004 can be written as 1, 2, 3, 4. 4 times 10 raised to the power of negative 4, right? And this is equals to 4 over 10 raised to the power of 4. Are you getting it? So 10 raised to the power of 4 is what? 10,000, right? So I'm going to have 4 over 10,000. Okay. Now, if you reduce this fraction to the lowest term, you're going to have 1 over 2,500. Do you understand? So therefore, 0.0004 equals to 1 over 2,500. Now, I'm going to replace this as 1 over 2,500. So I'm going to have logarithm of 1 over 2,500 base 50, right? So this will give me logarithm of, now, 2,500 can be written as 50 times 50, right? So I'm going to have 50 times 50 equals to 50 squared. Do you understand? So I'm going to have 1 over 50 squared base 50 log 50 raised to the power of negative 2, because 1 over 50 squared can be written as 50 raised to the power of negative 2, and the base is what? 50. Now you apply the log of a power here. The log of a power is the product of the power and the log. So these two will multiply the logarithm. I'm going to have minus 2 multiplied by log 50 base 50 minus 2 times 1, which is equals to minus 2. And that is the answer. Okay, you can use the second method. So let's log 0.0004 base 50 equals to a letter, which is x. Okay, we write this in index form. I'm going to have 50 raised to the power of x equals to 0.0004, right? 50 raised to the power of x equals to 1 over 2,500, right? So 50 raised to the power of x equals to 50 raised to the power of negative 2. Because the base are equal, I can set the power equals to the I can equate the power. So I'm going to have x equals to negative 2. Hence, log 0.0004 base 50 equals to negative 2. So the answer here is negative 2. Okay, let's look at more work example or questions on logarithm. Okay,
to watch the complete class, kindly click on the link in the description of this video or the comment section. Okay, see you in the next class.